Istio. My name is Diego Pacheco. I am Principal Software Architect at Allegra. I am Agile Coach. I have experience with SOA and microservices in production, and also I am a DevOps engineer practitioner. I wrote the book Building Applications with Scala and the video series Building Effective Microservices with Java and Netflix OS stack. Here's my GitHub, my Twitter, and my Blogspot. Today I want to talk about with you guys about Istio and why Istio is so important right now. And in the end, I'm gonna do a very quick demo running Istio locally. So before we talking about Istio, we need to talk about Kubernetes. So here we have a brief overview of Kubernetes architecture. We basically have a Kubernetes master node, and we have any Kubernetes minions or Kubernetes nodes. So basically, for a node, you're gonna have a Docker daemon inside that node, even if the image is not showing here, and also the kube proxy and the kubelet. Inside of the Kubernetes master architecture, there are some main components like the kube scheduler, the kube API server, which talks with the scheduler and the kubelets in the nodes, etcd, which is a distributed key value store written in Go. Also Kubernetes is written in Go as well. And then we have the kube controller manager and the cloud controller manager, which has a connector for specific clouds. And then you have AWS, you have Google, Azure, and so on. Kubernetes is pretty much important right now because it allows us to do multi and poly-cloud deployments, and we are not tied to a specific cloud vendor like AWS or Google. And then we have the flexibility to move our workloads or microservices for one cloud or another, and even use both at the same time using kind of a poly-cloud solution. So briefly, this is the Kubernetes architecture, and Istio runs on top of Kubernetes. So here there is some matrix comparing some features that Istio, that Kubernetes does for us. This is Kubernetes, and how this concept is implemented by Kubernetes. And also gonna use this to explain some of other Kubernetes concepts. So basically, there's automatic bean packing, which is mapped in Kubernetes with pods, pretty much. So a pod is an abstraction where you place containers. So your Docker image we're gonna run in pods. So if you have one or more Docker images running on a pod, you're pretty much sharing the network interface of that box, or you sharing volumes. So this bean packing is done by the pods. Horizontal scaling, we have pods auto-scaling. So we have the same capabilities we see in cloud, like we are using AWS, we use resources like auto-scaling groups, elastic load balancers, where we can scale our nodes as we need. And in Kubernetes we have the same deal. So basically we can scale, and this scale is pod auto-scaling. We also have self-healing, so we have this concept of replica sets, which pretty much is like when you have your auto-scaling group, you can define minimum, maximum, and desired size. And in Kubernetes, the replica sets, you can do kind of the same deal. So you can define how many instances you want to run, and you have this self-healing capability. So if they crash, Kubernetes will boot it up and put it online again for you. Also have service discoveries and load balancing, which is provided by services. So Kubernetes has a concept called service, and you can create services that will provide that capability. There are automated rollbacks and rollouts, and that's done via deployments. So in Kubernetes, we basically can do head black, we can do canary, we can split traffic, all this kind of goods. There are secrets, which are ways to manage sensible configuration. like passwords, tokens. There are configurations which are pretty much key value pairs, like think about any kind of a config, like a version, a name of a tag that you download from internet, a URL, wherever it makes sense for your configuration. And in Kubernetes, this is called config map. There are storage orchestration, which in Kubernetes we call persistent volumes, because Kubernetes run on Docker, so by default you're gonna lose everything there because it's ephemeral. However, you can define persistent volumes and then you're not losing the data. And also you can do batch execution in Kubernetes, then we use the concept of jobs. Now let's talk about Istio and modern cloud and cloud native microservice development. So first was the first wave with Netflix OSS, and that happened on 2014 pretty much. And Netflix was like game changed, introducing several important cloud native concepts like mid-tier load balancing and failover and circuit breaker with histories and so on. However, Netflix had some drawbacks with the stack because the stack pretty much is in Java, so it's very hard to use something that's not Java, like Node.js or Python Ruby, and then you pretty much need to integrate with sidecars and rewrite several protocols, and that's kind of hard. And second, you have some kind of a binary coupling because all of the stack pretty much is in jars in your class path. So sometimes it's very hard to update some versions of libraries like Guava, for instance, could be a hell, especially if you're using Cassandra and other libraries that commonly easily depends on Guava. So there was this kind of a second wave of microservices. We could say pretty much like end of 2017, 2018, where pretty much Istio is leading the way, where you have the combination of Kubernetes, Istio, and Envoy, which is a proxy from Lyft. So we still have the same benefits of Netflix OSS stack. However, Istio help us to remove some of the DevOps struggle because we want to do right now multi-cloud and poly-cloud. So we want to be able to run our workloads in different clouds and not be coupled with the cloud vendor. So we need to have some kind of infrastructure abstraction, and Kubernetes and Istio provide that. And also we want to reduce the infrastructure complexity. So Istio provides something called a service mesh capabilities, which will give us kind of the same benefits as Netflix OSS, however, not tied to Java, because we are pushing the abstractions to the platform, not to the application. So we can use any language like Python, like Ruby, Go, Rust, you name it, and we still can have circuit breaking, we still can have load balancing, we still can have discoverability, we still can do canary. And also Istio provide great observability, much greater to Envoy. Envoy has like lots of metrics and expose pretty much everything. And this is great because now microservice developer can focus on the business rather than on a stack, so they don't need to worry about operating microservices, and that's pushed to the stack. So I think that's a big shift in microservice development, and Istio provides that in a common standard way that we can do in any cloud, since we are using Kubernetes under the hood. So some definition here about service mesh. So service mesh is used to describe the network of microservices that make up such of applications interactions between them. So then is your stack, so you have all your microservices, they talk to each other and they have capabilities. However, when you start doing these microservices, this mesh becomes more complicated and more hard to maintain, and is still aim to reduce the complexity of doing this mesh. So like I was saying, as you grow up, you need more. So you need like discovery, you need load balancing, you need failure recovery, you need metrics, observability, monitoring, A/B testing, canary, rate limiting, and several things. Security, you might want TLS across every service call, etc. And Istio can deliver that with Kubernetes. So Kubernetes will deliver part of the work, and Istio will deliver the rest. So basically here we can see overall high-level Istio features. So Istio provides us feature for connecting. So we are able to have intelligence control between services, and we can gracefully do red-black deployments and shift traffic because of that. So that's a very interesting platform capability. Also, Istio is secure by default. There's several levels of security, and there's encryption and TOS between everything. And Istio provide control, so it's easy to apply policies and enforcements which they are not really present on Kubernetes. So easily you can have situations like you have a namespace and anyone can access that namespace, and with Istio you can introduce more control. And also, like I said before, Istio is very highly observable. So it's easy to know what's going on because it's rich, automating tracing and monitoring and logging for our service. Going on, still talking about the Istio features, there's automatic load balance for HTTP, for gRPC, which is Google with protocol buffers, WebSocket, TCP traffic. Also fine-grained control on traffic behavior with rich routing rules, retries, failovers, fault injections. There's a pluggable policy layer for configuration and API supporting, so access control, rate limits, quotas, automatic metrics, logs, traces between cluster, including cluster ingress and egress, which is inbound and outbound, secured service to service communication, a cluster of strong identity-based authentication and authorization. So it's the whole deal. Some of the Istio design goals, so when Istio was created, this was the design goals in mind. So the main design goal was to maximize transparency. So, program network layer route traffic. So basically in Kubernetes proxies, they are injected into pods. If you want, you can have the pod there, but also Istio has the capability to inject envoy there. And traffic is captured by programming IP tables rules. So it's the basic IP tables construct we have in any Linux. Istio is also designed with incrementability, so we need to have the ability to grow the system and add more features and policy enforcement. Portability, very important for poly and multi-cloud, so being able to run in any cloud or on premises and deploy on multiple clouds for redundancies, for instance. And also policy uniformity. So policy APIs provide great control over the mesh. So you can control quota for CPU. So let's say you're running a job for machine learning training. So then you can limit the CPU quota there. And that's important because it's a separate concept. So it's not all implemented on the proxy. So there's separation of concerns, which is very good for architecture. So here we can see part of the Istio architecture. Basically, there are two main components, the control plane and the data plane. So on the control plane, we have three big components, which is the pilot, which is the main component. Then we have the mixer and the Citadel. So the pilot configure data and proxies. The mixer checks policies and telemetries. And Citadel enforce security with TLS certification. Inside each node, you're going to have Envoy running on each microservice you have. And also Envoy, you're going to have load balancing, you're going to have caching. There will be multiple layers of caching, and Envoy also can do failover, can do rate limiting, a bunch of things. There are communication service to service where you do the mesh with Envoy. So Envoy is that proxy with the hexagon in pink, which is developed for Lyft, so that's why it's pink. And then you can have communication with HTTP 1.1, HTTP 2, gRPC, TCP, and we can have or we cannot have MTLS. So right now it's very cheap to have TLS, so it's very recommended to use TLS for everything. So that's kind of the overview of the control plane. And then we have the data plane, which pretty much is a mix of Envoy and the mixer. So for each service, there's a sidecar running an Envoy proxy, and then these envoys, they talk to the mixer, and then do logging, do quota, authorization, telemetry, and so on, so on. So there's communication between the services and communication with the mixer, and that's the data plane. Talking a little bit more about Envoy. So Envoy was developed by Lyft. It's a dynamic service discovery solution. It adds load balancing, TOS termination, HTTP2 and gRPC proxies, circuit breakers, and health checkers. So if you remember the Netflix OS stack, when you used to do these kind of things with, you expose an API, and then you have a health checker, or you do that with your ELB, ALB, or NLB on AWS. But often, like, the circuit breaker was done with Hystrix. Now Envoy is doing for you that part. And you also can do staged rollouts with percent basis traffic split, so we can do red black, and we can easily increment the number of percentage of traffic for users gradually, and Envoy help us to do that. Also help us to do fault injection, so it's easy to do network chaos testing, and it's very rich in sense of metrics. That's why Envoy is known for good observability. Here's a very, very overall view of Istio, but pretty much you have the ingress and egress on Istio, where the things get in and get out. So you're gonna have your firewall, your VPNs, but also there's security on every Istio sidecar with Envoy. So we have identity, we have policy, we have AAA, we have encryption, we have TOS on everything. Here we have a more granular view, and talking a little bit more about which component does in sense of security. So for instance, talking about the control plane, the Citadel does key and certificate management. The sidecar and perimeter proxies, they implement secure communication between client and services, which is also Envoy involved. The pilot, which is on the control plane as well, distribute authentication policies and secure naming to proxies. And the mixer on the control plane as well, manage authorization and auditing. And you also have, you can have MTOS communication, like end to end, pretty much. So this help us to not have any kind of a man in the middle, for instance. Talking about reliability, Istio was designed to achieve 99.999 reliability, and also to be low latency and heavy on caching. Because of Envoy and the mixer, we have for free 2-3 levels of caching, where first level is on Envoy itself, and that can reduce the network calls, and then you have on the mixer as well the second level. So this is great because it's very transparent for us. It still has something very cool called adapters, where we can integrate Istio with components that's not running on Kubernetes, or we can expose metrics and logs, for instance, and there is a great deal of adapters. You can check this link on the reference. There's adapters for CloudWatch, SignalFX, FluentD, Redis, Stackdriver from Google, StatsD, Prometheus, and so on. Datadog, there's plenty of adapters. You can create your own adapter if you need. So now we're going to do a very quick demo showing the potential of Istio. I'm running locally on minikube. So this is the architecture we're going to have. There's going to be an ingress, a gateway, which is using Envoy. So Envoy is pretty much in two places. Is on this ingress gateway and is inside of each microservice. Here we have 4 microservices. Each microservice is running on a different language and a different stack. So we have a microservices in Ruby, which provides book details information. We have a Python mashup, which generates a product page that orchestrates the other microservices, and it's kind of the UI, which is the product page written in Python. Every microservice has Envoy, which is the kind of brown Ruby bar. And then we have, in Node.js, we have the ratings. So you can rate the reviews of the book. And also there's reviews. And we can run multiple reviews APIs. So we can have multiple versions of the microservice, and we can have this kind of a split traffic. And here we are reviews we have written in Java, and there's 3 versions of the review API. There's v1, v2, and v3. So this is the application that will be running on Istio. So without further ado, let me show how I install it and show it running locally. So here you're gonna see this on my blog. So here's how I install Istio. It's very hard to learn Istio right now. I think the main reason why it's a bit hard is because it takes you to need to have a cloud. So maybe not all developers have cloud access. And second, if you're not running on the cloud, you run locally like me, you need to have a lot of memory, 8 giga at least. If you add more than 8 giga, it will be even better. But that's, a very, very heavy machine. Not all developers have it. So that's kind of the drawback, which sucks a lot of memory on minikube. And the process is a little bit cumbersome. Sometimes, when you are getting the pods, it gets some crash loopback, and then you need to delete the pod or even delete the whole minikube installation and go on and on. So here, I'm running with the newest Istio version. I recommend you to run the newest version, which is 1.5. And I put the versions for everything here. So we are using kubectl, the latest version as well, which is 1.13.0. Using minikube, the latest as well, 0.33.1. We're using Helm, which is a Kubernetes package manager, which helps us to install Istio, which we are using 2.12.1. Istio, like I said, 1.05. And we're gonna run Kiali, which is a visual representation of each Istio graph. It's very interesting, and also Prometheus. It's possible to integrate with other components, like you can use Grafana to see dashboards, and you can use Jagger for distributed traces, but today I'm going to focus just on these components. So basically, what you need to do is very simple. Here are all the comments, alright, and they are fixed with versions, so it should work even if there's new versions, right? One thing you need to keep in mind, sometimes you get some odd and bizarre errors, and that's because maybe you're using an old version of kubectl. I run into that sometimes, so that's a very important thing you to keep in mind. So first thing, you need to get kubectl. So as you can see here, I'm getting fixed 1.13.0. So you just download it and you move it to your bin, and then once you have kubectl, you should be able to run this command, kubectl, and it should be something like this. Then you're running kubectl. Right. Then you need to have minikube, and that's the slow part. You cannot just do once you download minikube. Pretty much everyone does minikube start. That won't work. You need to do more. So you're gonna need to specify that you're gonna use at least 8 gig of RAM. I'm putting a Kubernetes version 1.10, and also you need to pass this set files parameters, or won't work as well. And this line here will take a lot, because it will download like 200 giga from the internet, and then we'll do all the setups and restarts. This will take some time. Once you run that command, you need to do minikube status, and then you're gonna see something like this. Alright, host running, kubelet running, API server running, so it means it's all good. So then you need to install Helm, which is the package manager. This is pretty simple, as you can see. Versions are attached as well, so there's no mistake. Just copy, run it. And then Istio. So Istio here, you need to be careful, because when you download, you're going to get master. But we don't want to be in master, because things could change. So maybe this work, maybe this not work. So it's good to do a checkout tags, and then we are fixing to the version 1.5, which I made this and will work. Once you do that, then you can move the istioctl to your bin. So then there's a command called istioctl you can run. Istioctl can inject Envoy into a pod, which is something pretty cool. Okay, Now we'll move to the installation. So we're gonna use Helm, and with Helm we're gonna install Istio. So there's a template. So once you download Istio, you need to move into the Git directory, right? Let me come here. So you're gonna see there's this installed dir. With that, there is the files that we're gonna install. So we need to be pointed there. So as you can see here, I am on my Istio download, and I see these folders here below it. That's where you need to be. Then you basically can run hell template, and this will create a Istio file with a template there. Once you do that, you can run kubectl, create a namespace for Istio. It's called Istio system, and then you can apply. This will style multiple Istio components, and will take some time, especially for the pods. So when this is done, there is a kubectl command we can run to check the pods for Istio. So Istio is in a separate namespace. So if you don't pass -n Istio system, you're gonna see the default namespace, which is like public or kub public, which won't be the infrastructure, because we separate the infrastructure and the microservices in different namespaces. So when I run this, you're gonna see at least these components. You're gonna see like on the mixer control pane, we see Citadel, we see the pilot, which is the most important one. We're gonna see some things like completed, like this. These are cleanup secrets, things that run like after install, so that's fine. And you should be seeing everything running. You might get to this state where everything running could be easily 10-20 minutes, depending on your network and your machine, because as I said, some pods might crash, and then you might need to do things. You won't see Kiali right now, because I'm seeing here because I did before, but you won't be seeing Kiali. There's some steps to get it there. Okay. So then there is this application book info that we saw the architecture on the slide deck, this one here, which we will run it. So in order to do that, there is this command here where we're gonna use Istio to inject Envoy and all the Istio parameters on this YAML for the book info application, right? And then we can do get service. As you can see here, I'm not passing the Istio namespace. You should be able to see product page, ratings, and review, which are the three main in details. So the four microservices that we saw on this diagram, 1, 2, 3, and 4 different languages, by the way. And then you can do get pods or simple PO, which is abbreviation. And then you're gonna see the pods running. Again, this might take some time to run it. As I said, first time downloading Docker things, it takes time. Then you need to create a gateway, right? That's the ingress gateway, and there's a command get gateway. You can see it there, right? So now you can test the application. So in order to test it, we need to get the minikube IP, because minikube is running on a virtual box. So the IPs that are there are private and not exposed to my machine. So with that IP, I need to get the port of my gateway. So there's a command here, which I changed it. You're gonna see this command a lot on the internet. Most of the times it's wrong because it just doesn't work anymore. But this one, I changed it and should be working. So there's an annoying thing when I copy something here, like yes, this is the thing. Yeah, here. So you see, that's the port. It could be the same port for you, maybe not. So that's the safe way to do it. So I did it in a way that goes to a URL variable, and we have everything pronto at once. So basically, we can do a echo here, and then you can see like the whole thing. So this is the thing. So then we can do a CRL. Will take some time, and we're gonna see a 200, which means the application is working. Yeah, and also we can open this on the browser. You can just copy, or if you want to be fancy like me, you can do xdg open and then the URL. It opens the browser for you, your default browser. Mine is Chrome, so it should be here. So here we can see the whole application working, calling all microservices. You can see the whole thing fully working. Pretty cool, huh? Awesome. So let me close this. Let me see what else I show you guys. So Kiali, you just need to run this line here, and then it will install Kiali for you. Then there's a similar deal, like we need to get the port. I made a command that gets the port and open in the browser for you, because this URL is a bit harder to guess it, right? But it's there. And then with that we can see kind of a visual, you need to proceed, it's unsafe. And then there's this console where you can see what's going on. There's this beautiful graph views that it generates for you, and it's pretty sexy. Here you can see our whole architecture. We can see the calls going through, the traffic. We can see how many are okay or not okay. This is so nice. You see, this is very cool. I love Kiali. Yeah, it's amazing. Okay. Also, because I said, let me close here. It's possible to Prometheus as well. Prometheus is already running. I just need to do some port forwarding. So when I do that, I cannot close this tab because it's forwarding the port for me. So it's not running on my 99 port. So if I just copy this, I can see Prometheus here. I already get a metric, so there's tons of metric here, and then you don't figure out which metric you can look. So I get some request counts here, and I put it on a command as well, xdg, so it will open for you. Or you can just copy the URL and open the browser. So we can see some requests going through. There's these numbers because I was doing some requests before. Cool. All right, so that's it. We are running the application with Istio, Prometheus. That's it, the live demo. I hope you guys enjoy. At the end, the only thing you need to do here is run minikube stop. And the second time that you do a minikube start will be fast, and you just need to do a minikube start. You don't need to pass all that parameters I did. I show you on the gist. And it will just be the time to boot up the containers, right? Will take some time, but will be definitely faster. So this is it, guys. I show you how to run Istio locally. You need to have some patience and memory, because as you can see, my load average is high, not only because I'm recording the video, but my memory is using a lot of memory. But it's a cool technology, and there's lots of potential. So that's it, guys. Thank you so much.